In this question, a cube of side 0.1 meter is placed as shown in a figure. This is a cube here. It is placed at a distance of 0.1 meter from the origin, where the electric field is equal to 500 x I naught. It means that based on the value of this x, the electric field value will change. So it's a non-uniform electric field. It's not constant. Based on this information, we have to find the flux passing through the cube and the charge within the cube. So as we know that flux is equal to, it can be represented as phi, it's equal to E dot ds. So E is the electric field and ds is the surface vector. So if the electric field it's on the x-axis, because it is I cap, so we can make the direction of electric field in the positive of the x-axis. So as you see, we have a cube here. So this cube has 6 faces. This electric field will pass from all the 6 faces, but the area vector is everywhere it's changing. Means suppose for the top one, this is the ds value. For the down one, this is the ds value. And here this is the ds value. This is the ds value. And back side is ds value. And one is the front. So there are total 6 surface vector. But as we know that flux is equal to E ds cos theta. Cos theta is the angle between electric field and the area vector. So in the top one, as you see, if we consider this top one, E and ds will be perpendicular to each other. So in this case, theta is equal to 90 degree. So we can say that for the first one, top one, flux will be 0. Similarly, bottom one, flux will be 0. Front one, flux will be 0. And the back side, flux will be 0. So flux is only present on the left side and the right side. So if we consider for the electric flux in the left side, so in this case, flux is equal to E dot ds cos 180 degree, because electric field is in this direction and surface area in the opposite direction. So it will form cos 180. So flux is equal to minus E dot ds. So here E is given as 500 x I cap. So flux we can write it as minus 500 x into area is 0.1 whole square, because its side is 0.1, so area of a square is side square, and x distance is 0.1 meter. This is 0.1 meter, so we can write it as flux is equal to minus 500 into 0.1 into 0.1 whole square. So flux will come as minus 0.5 Newton meter square per coulomb. Similarly, flux on the right side, phi is equal to E ds cos theta. Here theta will be 0 degree because both are parallel to each other. Electric field and the surface area both are parallel to each other. So flux is equal to 500 into x into 0.1 whole square. So in this case, x will come as 0.2. Why it is 0.2? Because this distance is 0.01 and this thickness is, or the side is 0.1, so total is 0.2 meter. Now after that, flux is equal to 500 into 0.2 into 0.01. So flux is equal to 1 Newton meter square per coulomb. Now net flux, this is for left, this is for right. So total flux is equal to flux of left plus flux of right. So minus 0.5 plus 1 is equal to 0.5 Newton meter square per coulomb. So this is the answer for the first part. In the second part, we need to find the charge inside the cube. So for finding the charge inside the cube, we can use the Gauss law. So Gauss law is flux is equal to Q by epsilon naught. So Q is equal to flux into epsilon naught. Flux we got it now 0.5. Epsilon naught is 8.85 into 10 to the power minus 12. So net charge will come around 4.425 into 10 to the power minus 12 coulomb. This is the answer of the second part.